Hello, DevSecOps Canada 2024, and thank you to the organizers, in particular Garima Bajpai, for inviting me to speak today. So we're going to cover something that we like to call State of DevSecOps in 2025. Now, I'm not going to be able to cover a report like a Sonatype would do, but I am going to look ahead to the challenges that's facing DevSecOps engineers, developers, and CISO officers as we move into this cybersecurity problem in 2025. I'm Tracy Ragan. I am the CEO of DeployHub. I also serve on the governing board of the OpenSSF Foundation at the Linux Foundation, and I'm also on the board of the Technology Oversight Committee for the Continuous Delivery Foundation. So I have a special view of the intersection between dev and sec and ops when it comes to culture, the challenges, some of the new standards in reporting, the need for training, and new tooling for CI/CD pipelines, all of which we will be covering today. My background, I've been in what we call now DevOps my entire career. I've been working on configuration management, application lifecycle management, CI/CD, DevOps, DevSecOps, whatever you want to call it. At the end of the day, it's all about automating the software factory floor, and it's time we begin thinking about how to build security into that process. Because, according to JFrog, it takes a whopping 227 days to contain a software supply chain attack. That is crazy, and it's become a persistent problem for us. In fact, I was on a call recently with some of the folks from Sonatype, and they said that some people are still downloading Log4j and Log4Shell that had the vulnerability that cost globally about $10 billion. People are still downloading it. It's still in scripts. So it's a persistent problem. It's hard to get these vulnerabilities out of the supply chain once they are there. And because there's so many coming through that pipeline, developers and security teams and DevSecOps engineers, they really struggle to manage this relentless influx of vulnerabilities. And it can impact thousands of components, and at the same time, we're building more complex software. Kubernetes and microservices create a very complex environment from which to start managing these vulnerabilities. Because if you think about it, one vulnerability could be in multiple containers, and there are thousands of containers running across organizations. So you may have to take one vulnerability, and it's not just updating one monolithic application. It is updating every container across your environment. So this is a big problem. There's a lot to talk about, a lot of problems to solve, and we haven't even started talking about the problems that AI create when it comes to security. It's a whole new ballgame with tons of agents, these AI agents running across all these containers. So this is an area we need to get under our belt. We need to really understand what we need to do to change in the way we see things, the way we think, and how we collaborate to solve these problems. I pulled this out of an article I was reading that quoted Gartner, claiming that they predict that in 2025, we will see an alarming 1.5 million vulnerabilities. They say it'll triple from what we had in 2021. So I looked at what 2021 was, and it was about 600,000, which is about what we're going to have this year. But they claim that it will triple in 2025, with 58% of those targeting federal sectors across the globe. So there's an onslaught here that we need to start thinking about. Whether this is a real number or not, 600K is still a lot. We'll probably have somewhere around 750 vulnerabilities coming across the pipeline in 2024. Let's say 2025 is 1 million. It's still too many, and we have to automate in order to start addressing this. Personally, I don't believe that we can code scan our way out of this vulnerability issue. I do believe that we will need better ways of managing and addressing vulnerabilities as they come across the pipeline. I like to think about chaos engineering as applied to the security problem. we need to understand response and how we can respond quickly. That is as important as learning how to scan and prevent new vulnerabilities coming through the process. But we haven't gotten there yet. So let's look at some of the cultural issues that we face when it comes to the security, solving the security or the cybersecurity problem. One of the biggest ones is, and I see this all the time, is security is someone else's job. This is a mindset that is pretty prevalent across organizations. So who owns that responsibility? Who owns the tools? How do the tools fit into the process? Who gets to select the tools? Does each team, depending on the language they're using? So we're pretty fragmented. We're pretty siloed within the organization. CISO tends to be the ones looking at the security problems, but it's developers who are the ones who need to address the security problems early on. Maybe DevOps teams need to do a better job of building controls and guardrails within the pipeline, and production needs its own way of responding quickly. So we all have a role to play in this problem, but the cultural silos prevent us from solving it. Honestly, I see this when I work with the OpenSSF and the CDF. The CDF, they're very focused on the pipeline and making sure these pipeline tools are working as intended and have new features and can support and scale to these cloud native environments where we have thousands of workflows being pushed across the pipeline every day. And then on the security side, on the OpenSSF side, I see tools being created that are some of them are command line based. Some of them are focused on just finding the open source projects that need help and solving security for them. But we don't necessarily have a conversation together of how we can marry these two problems, because the tools that are being written for security, most of them are being designed for the development process. We still have to see more tools that can give it visibility and insights for the CISO teams so they understand their risk. But we have a lot of discussion to do, and these silos can cause security to be somebody else's job. Okay, we've been working very hard. When I say we, I'm going to say the DevOps community in general have been working really, really hard to build systems that allow us to do high-frequency software deployments. Decoupled architectures, we're deploying all the time. But if we add security to the process, does it really mean that we have to do the deployments are going to be slower and we're going to take longer to get features out? Well, tight deadlines and pressures to deliver, features are what, it says results in security being deprioritized. Security and testing sometimes get pushed back because we want to get a new feature out. We can't do that, right? These are steps that have to be added to the process of frequent deployment. So how do we do that easy? So security must be a corporate-wide initiative as well. In order to understand and to discuss that deployments aren't going to be slower if we start automating the pipeline to add some of the tooling so that we can have insights and fix things, we can take more of a chaos engineering approach and say, we know this just got deployed, we need to get it fixed. Because vulnerabilities are going to get out into your systems. So how do we respond to it? But security in general has to come from the folks above. Because if we're thinking about the DevSecOps pipeline, we all understand that it's going to take some money and effort and focus to add tooling to the DevOps pipeline. In a recent TOC meeting I was at the Continuous Delivery Foundation, I was alarmed to hear that the idea of adding SBOMs to Jenkins hasn't really been a big discussion. Why not? It's a simple step. Well, does everybody want to start updating all these workflows? Are they being paid to do that? Does upper management understand the need to do that? maybe not. So a lack of awareness and training. Boy, this is a huge problem, a very big cultural issue that we really should be thinking about solving. A limited understanding of secure coding practices. Again, if upper management is not focused on cybersecurity and in particular software supply chain security, are they going to spend money on training developers to understand secure coding practices? Or spend money on the DevOps pipeline to integrate more scanning tools, or spend more money on those types of tools? Technical debt has always been a discussion, which is why open source has become so important. The good news are there are open source tools that we can incorporate into the pipeline, but we have to have the backing to start popping up the hood and doing some work on our vehicle here. And underestimating risks. I don't know if teams can fully grasp the potential impact of security breaches. According to IBM, they claim a vulnerability can cost an organization about $5.5 million. That's a lot. So if we start looking at vulnerabilities in terms of cost, then maybe we can start challenging some of these cultural biases. And training and awareness about security will be more important if it's painful. And oftentimes, painful means cost. So how do we start reporting the costs associated to vulnerabilities? I don't know. But it's an area that needs to be explored, and it will improve this cultural challenge. The awareness of vulnerabilities, their cost, their impact, and why we need more training. The truth is, we have a lot of tools out there, but we still have vulnerabilities hitting the system. So maybe the existing tools that we're using are just not doing the job. It's not been that long since we've really started addressing vulnerabilities. There's a great book I highly recommend everybody read. It's called They Tell Me This Is How the World Will End. And it is a story about the zero-day vulnerability market. You begin to understand that there was a point in time that these vulnerabilities were buried by big companies and our government. And in fact, our government used them themselves until some of the hackers decided that they were not getting paid enough to find them. And instead, they would begin reporting them. Shows like Black Hat is a result of that. So we are looking for a real disruption here. We have a false sense of security that the automation we currently have is doing enough, but it obviously is not. We need new tools. We need new ways of finding problems all the way from code to cloud after the container is built. And sometimes I think teams can feel overwhelmed by all the alerts that multiple tools have, and we have to go to so many different dashboards to find it. So I just don't believe necessarily that the existing tools that we're using work well enough together and are doing the job that we need done, because sometimes we begin ignoring that. I mean, let's just go to something very basic. I'm sure if you ask the question, if you're a developer and you're looking at your build output, do you really address all those compiler warnings? Maybe you do, maybe you don't. Maybe the high-level warnings you address, but maybe not some of the other ones. I know I didn't. I didn't always fix every single warning. I did the important ones, but not necessarily all of them. And that's sort of how we're treating vulnerabilities. And sometimes we don't even worry about the high-risk ones. We just move forward because we've got too much to do in our jobs, and we're relying on the tools to just address it for us. But maybe that's not working out so well. So let's just walk through some ways of addressing these issues. There's quite a bit we could talk about in each one of these. I've picked 6 areas, and there's a lot to discuss in each one of those. So let's just start with one I call the DevSecOps culture. We must start thinking about DevOps as DevSecOps and begin thinking about what tools we need to integrate into the development workflow in the CI/CD workflows. This probably is one of the easiest ways for DevOps engineers to start playing their role in solving the problem. For example, if you are not generating an SBOM, start. Now I get it, because if you're generating an SBOM and you're doing nothing with the data, what's the point? But let's just get started doing that. Let's just get the SBOM generated, even if you just check it into Git, with all your other artifacts. Second, a culture of education. This is going to be an ongoing problem over the course of the next 5 to 10 years. And security is tricky because it constantly changes. I was just on a call that talked about prompt injections in AI and large language models, where you can use a prompt injection the right way to potentially get access to sensitive data. It's going to happen. So we have quite a challenge in front of us if all we're focused on is trying to build out the next cool AI application, and we're not integrating security into the culture. So as DevOps and DevSecOps engineers, getting those workflows completely refined and rebuilt and pushing for funding to do so is going to be the role that you need to play. And an education culture. This, being able to have the awareness and skills that the company will pay for, you also need to advocate for. Some of you in big companies have a bucket that you can use for training, but you may want to focus on training in AI. I encourage you to focus on training in security, because right now that is what we need to do in order to address these software supply chain vulnerabilities at a minimum. Hackers are working at it. They're figuring out ways to break in. And how do we understand how we protect ourselves with both a shield at the door and a sword if they get in the house? So we have to have both offensive and defensive techniques. And an education of culture is important, as well as sharing. Collaboration between the teams, between your DevOps teams and your development teams and your security teams and your operations folks and SREs. We have to all start talking to each other so we understand the risk level that we're facing. We understand the challenges that each of us are having in addressing this. And maybe by breaking those bubbles and bringing ourselves together and collaborating around this particular topic, we can solve some problems. Leadership. Leadership has got to align priorities to support a security-first mindset. If we're in a factory, we say safety first. We don't do that in software. We don't think safety first. And what we should be thinking is safety is security, so security first. What we think instead of security first means a slow release cycles, or I have to work late without being paid. There's some serious culture issues we have to sit down and look at that answers the question why we don't have our leadership prioritizing around a security first mindset. And then adoption. There are challenges with security tools. Many of them are not developer friendly, and not all of them integrate easily into workflows, which is where they need to be. We can't run security tools on every single container. We have to automate that. And everybody knows that, but we still see tools that are not being brought into that DevSecOps pipeline. We have a DevOps pipeline, and maybe we have a SecOps pipeline that calls these tools. But gathering the information together and starting to manage and track the logs is where we're going to get the intelligence to start building real AI tooling around our DevSecOps processes. And I know years ago we talked a lot about fail fast culture, but we need to have a blameless culture when it comes to vulnerabilities ending up in production. This is a hard challenge. We are building far more complex software systems with thousands and thousands of dependencies that we cannot track as a human. We have to allow the computers to do that tracking, and we're going to have to start using more intelligence to start creating that shield and that sword to protect ourselves and build those cybersecurity guardrails around the software supply chain. So it's no one's fault right now. And the faster we figure that out, we fail, we fix, we fail, we fix. We take that sort of chaos engineering approach. We get really good at responding. That's when we're going to start really succeeding in our DevSecOps processes. And today, in 2024, looking back, we've not done that. But the state of software security in 2025 had better start building around these principles. And that fail fast and blameless principle is critical to it. So here's a few ways that you yourselves can address some of these problems. Get trained. The Linux Foundation has a pretty interesting course around developing secure software. It has been written by the team at the OpenSSF, who have spent a lot of time looking at this problem, working with government, and really doing some of the hard work. I would highly recommend you take a look at it. Do a search out there on LFD 121. You can go to the OpenSSF site, or you can simply do a search on Linux Foundation LFD 121, and it'll pop up. Take the course. You'll get a badge, and you'll thank me for doing it. I should take it while we have some quiet time. I've gone through some of it, but I've not finished it. But it's a good course written by David Wheeler, who has really spent a lot of time building it. I think they had about 7,000 people take it last year, so we're on our way. Next year, be one of those 7,000, or let's get it to 15. There are a host of new standards to study, and they're really quite fascinating. Ever since Log4j, the Biden administration came out with their executive order that says, hey, folks, we need an SBOM if you're going to do business with us. We want to know what you're consuming. We want to know what packages you're using. The government has pushed new studies, and industry like Sonatype, IBM, Apple, Microsoft, the Linux Foundation has been involved in building some of these standards and writing these reports. The Secure Software Development Framework is an important document to read. It brings up some old information. It's a good reminder, but it pulls together what the standards really should look like for building that software development framework. Some of you may not have implemented all of them as of yet, so it's good to read. And for those of you who have implemented some of them, you might find some tweaks you might need to do. So I would take a look at it because it does really it focuses on mitigating the risk of software vulnerabilities. Again, we can't stop them, but we can put up some shields and use some swords to protect ourselves. Again, NIST, the cybersecurity framework. This is a great guide to both industry and government to manage many different kinds of cybersecurity risk, including software. So between these two documents, it'll get your juices going. You'll start thinking about the security in a different way. And it doesn't take as long to take the class takes much more time. You're going to learn a lot more. But just reading these two documents will get you kind of set up to think about how we should be managing vulnerabilities moving forward in 2025. So these are the two from NIST that you should take a look at. Now, IBM X-Force really talks about data breaches, the cost of data breaches, the impact. And if we want to start pushing upper management to be more serious about it, you can pull some information out of this document. Vulnerabilities and data breaches are extremely costly. Many of them come from vulnerabilities coming through the pipeline that allow for those data breaches. So get informed. This is a good one. I enjoyed, it's easy to read. It gives you some interesting observations. And they talk about the security events that we're having to deal with across 130 countries. It's outstanding, actually, if you think about the challenge that we have. It's sort of epic, and this document really covers it for you. Be curious. That's all I ask you to be curious. start exploring some of the new tooling coming out of the open source communities. Ortelius is one that I'm involved in. Its job is to consume low levels DevOps data and DevSecOps data. So take your DevOps data that knows where objects are being deployed to, artifacts are being deployed to, map that with the SBOM, and then continuously look at OSV dev to know for a version that's running out in your production environment that a new vulnerability just showed up. So now you have a high-risk vulnerability that didn't show up when you did the scan at the time the container was built. So it's doing continuous vulnerability management. So it's detecting new vulnerabilities based on that SBOM that I encourage you to take a look at and adding to your workflow. The other thing it does is it looks at the OpenSSF scorecard, which we'll talk about in a minute. But it provides a dashboard for multiple security tools and pulls in the DevOps information and versions that so that you can see what's running in your production environments without having a container, a container scanning agent installed on all your endpoints. It does it based on the data collected from the CI/CD pipeline, where that information is generated. And it keeps looking at OSV dev to report on new vulnerabilities. So the OpenSSF, they've got quite a few new projects. It's hard to keep track of them all. I point out these two because they're specific to Git and GitHub, and most all of us are using GitHub nowadays. All-Star is a GitHub app that monitors GitHub organizations or repos to see if they're adhering to some basic security practices. OpenSSF scorecard, Open Source Security Foundation scorecard, it assesses open source projects for security risks. They have automated checks that you can add to your repo to really help improve the health of critical projects and give consumers of those open source projects and packages some insights on how well managed they are. So go to openssf.org for some of this information. And then collaboration. We talked about collaboration as a cultural issue. There is a lot of work to be done. You can get involved in working groups or what's called SIGs. I highly recommend getting involved in these projects. So at the OpenSSF, you can get involved in best practices for OS developers, security tooling, vulnerability disclosures, and supply chain integrity. Those are a few of the working groups that you can take a look at the OpenSSF. Again, there's a lot going on at the OpenSSF when it comes to security. They're working really hard to build out solid solutions and standards for you to follow, as well as education and training. So they're trying to break some of those cultural norms. And then the CD Foundation. There's a new special interest group you could potentially get involved in. We're just starting it in the new year, and we're really going to look at cybersecurity as it relates to the CI/CD pipeline, looking at some of the standards, the secure software development framework. What are the tools that we need to add to each of the steps in the dev test prod lifecycle? What are we missing? What are there open source tools that can fill those gaps? What are the commercial tools that we should be including? How do we take a fragmented development platform and architecture and start aggregating information up so we have more information than just a single container at a time? Because in our new world, in a decoupled architecture, you could have 50 microservices that make up a single application, which means you have 50 SBOMs and you have 50 objects to worry about vulnerabilities on. So this information has to start getting aggregated up, and we're going to take a look at that in this new CI/CD cybersecurity SIG. And you're welcome to attend it and give us your input and collaborate. Thank you so much again to DevSecOps Canada 2024. If you want to chat about any of these topics, reach out to me at LinkedIn. I'm at Tracy-Ragan-OMS. You can find me also on the DeployHub site. Visit there. And if you're interested in doing continuous vulnerability management, reach out. Thank you so much, and I hope you enjoy the show.